Hello everyone and welcome to our channel Mootechie. It's wonderful to have you here. Today we're diving into a fundamental skill used everywhere from electronics to metalwork, the fascinating world of soldering. So let's get started and learn all about how we join metals together. Now let's move on to our first concept. Soldering. Soldering is a process in which two or more metal items are joined together by melting and flowing a filler metal into the joint. The key point here is that this filler metal has a relatively low melting point compared to the melting point of the metals to be joined. Next, we explore the different ways this is done. Types. There are two main types we need to understand. First, A. Soft soldering. This is characterized by the melting point of the filler metal, which is below 400 degrees Celsius. The filler metal used in this process is called solder, and it's typically an alloy of tin and lead. It's used extensively in sheet metal work for joining parts that are not exposed to the action of high temperatures and are not subjected to excessive loads and forces. A suitable flux is always used to prevent oxidation of the surfaces to be soldered. And did you know? Zinc chloride is the most common soldering flux for this type. Now B. Hard soldering. This employs solders which melt at much higher temperatures and are stronger than the soft soldering ones. The temperature of various hard solders can vary from 600 to 900 degrees Celsius. When an alloy including silver is used as the solder to join the parts, it is specifically known as silver soldering, a common form of hard soldering. Coming up, we'll discuss the primary tool of the trade. Soldering iron. A soldering iron is a device for applying heat to melt solder for attaching two metal parts. Picture this, it's composed of a heated metal tip and an insulated handle. Heating is often achieved electrically, by passing a current supplied through an electrical cord or a battery through a heating element. Another interesting heating method includes the combustion of a suitable gas, which can either be delivered through a tank mounted on the iron itself, making it flameless, or through an external flame. Following this, you'll notice we need more than just the iron. Tools needed for soldering. Let's go through the essential toolkit. Safety glasses. These are absolutely crucial to protect your eyes against melting solder particles and flying lead pieces during wire cutting. Of course, the soldering iron itself, a wire cutter, and a damp sponge used for cleaning the tip of the iron. As we continue, let's understand why this process is so widely used. Advantages of soldering. There are quite a few. Number 1. Low power is required. Number 2. Low process temperature. Number 3. No thermal distortions and residual stresses in the joint parts. That's a big benefit. Number 4. The microstructure of the base materials is not affected by heat. Number 5. It's an easily automated process. Number 6. Dissimilar materials may be joined. That's very versatile. Number 7. A high variety of materials may be joined. Number 8. Thin wall parts may be joined without damage. And number 9. Only a moderate skill of the operator is required. It's quite accessible. Moving forward, we'll see the role of a very important substance. Soldering flux. First, the name flux means flow. Its job is to improve the flow of a molten metal. And interestingly, chemicals that limit the flow of a metal are called antifluxes. Now what exactly does flux do? Let's look at its functions. 1. It acts as a protector. It covers the metal surface and prevents oxide formation. 2. It's a reducer. It helps to reduce the oxides already present on the metal surface. And 3. It works as a solvent. It dissolves any oxide presence and removes it, cleaning the joint. So what is this stuff made of? Composition of a flux. Common fluxes are tailored for different metals. For instance, ammonium chloride is used for soldering tin. Hydrochloric acid and zinc chloride are used for soldering galvanized iron and other zinc surfaces. Borax is the go-to flux for brazing or braze welding ferrous metals. Other components can include boric acid and silica. Now what about those chemicals that do the opposite? Antiflux. Antiflux is used to control the flow of the metal, to stop it from going where you don't want it. The most common antiflux used is graphite. And for better control, fluxes like rouge dissolved in chloroform can be used. Let us now look at the actual step-by-step process. Method of soldering. The following are the stages involved in soldering work. It's like a recipe for a strong joint. Number 1. Clean the surfaces to be soldered. A clean surface is essential. Number 2. Keep the surfaces to be joined close together. Number 3. Apply a thin layer of flux with a brush. Number 4. Heat the soldering copper, that's the tip of the iron, to the proper temperature. Number 5. Tag the seam by applying solder at several points to hold it in place. Number 6. Begin at one end and move the copper bit slowly, adding solder as needed, watching it flow beautifully into the joint. And finally, number 7. Allow the joint to cool naturally without disturbing it. This is why it's important to understand the reasons behind using flux. Reasons for using soldering flux. 1. To clean the surface of the base metal during heating. 2. To eliminate impurities present in metals. 3. To break down the surface tension of the metal and enable the solder to flow smoothly. 4. To prevent the formation of fresh oxides by forming a protective layer on the solder. And what is all this knowledge used for? Uses of soldering? Soldering is used to join the following. 1. Electrical components in television, radio, transistor, and tape recorders. 2. Electronic components like printed circuit boards, the backbone of modern electronics. 3. Automobile parts like radiators. 4. General sheet metal works. 5. Common utensil repairs. Now, let's introduce a related but different joining method. Brazing. Brazing is the joining of two metal pieces by means of heat and a special filler, which is a non-ferrous metal. This filler has a melting point above 400 degrees Celsius, but crucially, it's lower than the melting point of the parts to be joined. Let's understand brazing in a bit more detail. Copper base and silver alloys are commonly used as filler metals for brazing. In the brazing process, the two metal pieces to be joined are first of all meticulously cleaned to remove all grease and oxide. The parts are then fitted together along the line of the joint and held in that position by some kind of clamp. Borax is a widely used flux here, though many other proprietary brands are also available. And here's a new term for you. The filler metal used for brazing is known as spelter. The actual heating may be done in different ways, leading to different brazing methods. These methods are classified as torch brazing, furnace brazing, resistance brazing, and immersion brazing, among others. So how do soldering and brazing really compare? Let's break it down. Soldering versus brazing. Soldering is a metal joining process where the melting temperature of the filler metal is relatively low. The most common type of filler metal used in soldering is a 60:40 tin to lead alloy. Soldering occurs at temperatures around 400 degrees Celsius. And because of this, soldering is a softer metal joining process where the metal's parts are not held very tightly. On the other hand, brazing is a metal joining process where the melting temperature of the filler metal is usually above 450 degrees Celsius. Brass alloys are commonly used in brazing. Brazing occurs at temperatures above 450 degrees Celsius. And this results in a much stronger bond. Brazing creates a tight fit between the metal parts joined. Finally, let's place them in an even broader context. Comparison between welding, soldering, and brazing. Let's read this table in a clear spoken format. Point number 1, on joint strength. In welding, these are the strongest joints used to bear the load. The strength of a welded joint may be more than the strength of the base metal. In soldering, these are the weakest joint out of 3. They are not meant to bear the load. They are used to make electrical contacts generally. In brazing, these are stronger than soldering but weaker than welding. These can be used to bear the load up to some extent. Point number 2, on temperature. For welding, the temperature required is up to 3800 to the power of Celsius in the welding zone. That's incredibly hot. For soldering, the temperature requirement is up to 450 to the power of Celsius. For brazing, it may go up to 600 to the power of Celsius. And point number 3, on heating the workpiece. In welding, the workpiece to be joined needs to be heated till their melting point. They are fused together. In soldering, there is no need to heat the workpieces themselves to a high temperature, just the solder is melted. In brazing, workpieces are heated, but they are kept below their melting point. And that brings us to the end of our lesson today. Thank you for joining me on this journey through the essentials of soldering and brazing. I hope you found it clear and inspiring. Remember, these skills connect our world from the smallest circuit board to the strongest metal bonds. Keep learning, keep exploring. Thank you. See you in the next class.